Assalamu alaikum. Welcome to the lecture 6 of Unit First. Now the next topic is factors causing turning on of SCR, or we can say we have different turning on methods of SCR. When the forward voltage is applied across the anode to cathode terminals, it can be turned on by any of these following techniques. The first one among that, this is called as forward voltage. This is called as forward voltage triggering. Next one, this is called as thermal triggering or thermal turn on. Third one, this is called as gate triggering. Fourth one, this is called dv by dt triggering, or rate of rise of anode to cathode voltage. And the fifth one, this is called as light triggering. And the most efficient method of triggering among these is this gate triggering. Mm. Now the first one is this forward voltage triggering. That means forward voltage triggering, this is not efficient method of triggering, and it results in unwanted turning on of SCR, causing the destruction to junction J2 of SCR because of breakdown. In this method of triggering, forward anode to cathode voltage is increased beyond breakover voltage, causing the breakdown of junction J2 and thus resulting in the removal of depletion layer across the junction J2, which in turn results in large amount of forward current. After this breakdown, junction J2 loses its blocking capability. Therefore, if forward voltage is reduced below breakover voltage, the SCR still remains in the conduction and can be turned off only by reducing the anode current below holding current. Now, the next method of triggering is the thermal triggering. In triggering, we are just applying only the forward voltage. We are not applying any gate current. That means, and here also junction J1, J3 are forward bias, and the reverse bias is only across the junction J2. That means this is during this forward blocking, most of the forward voltage is across the junction J2. Voltage across junction J2 with this and this small leakage current results in the raising of temperature across the junction J2. When the temperature of this junction increases, this may result in the more electron hole pairs due to the breakdown of the covalent bond. These charge carriers cross the junction J2, they gets accelerated and they gets accelerated and strike with the covalent bonds of the silicon to form more electron hole pairs. And this results in the new minority carriers. With these minority carriers, the layers becomes flooded with the layers N1 and P2 becomes flooded with these minority carriers, and they lose their semiconductor properties. Or we can say they behave like a conductor due to the large number of thermally generated carriers. Hence, here, since it behaves like a conductor, that means it's turned on. Thus, this in this thermal temperature triggering, no gate current is applied. However, this is not the efficient method of triggering, as it increases the junction temperature, which reduces the voltage withstanding capability of the device. Gate current. It is the most simple, the most reliable, and the most efficient method of triggering. In this case, the thyristor works with normal working positive voltage and positive gate current. Here, the SCR is turned on as the inner P2 layer is flooded with the electrons from the cathode, resulting in the reduction of depletion layer across the junction J2. This causes the junction J2 to break down at the applied voltage lower than the breakover voltage. So, higher the value of gate current, lesser will be their breakover voltage. This is shown in this figure where the gate current Ig2 is greater than Ig1 and greater than Ig and greater than Ig, and the breakover voltage for this gate current Ig2 is V2, for Ig1 is V1, and for this Ig is VBO. That means this represents that higher the value of gate current, lesser will be its, as this V2 is less than V1 is less than VBO, lesser will be its lesser will be its breakover voltage, and quickly it will be turned to its it will be turned on and will remain in its on. Also, once this SCR is turned on, it remains in its on state even if the gate signal is removed. But it should be kept in mind that if gate current is removed before the anode current attains some minimum value called latching current, SCR will turn off. So, the gate pulse width should be chosen such that the anode current reaches above latching current when the gate current is applied. Thus, this latching current can be defined as the minimum value of the anode current which the SCR must attain during the turn on process to remain in conduction when the when the gate signal is removed. For turning off of thyristor, for turning off of the thyristor, we are applying the reverse voltage, and for this, by applying this reverse voltage, the anode current, our forward current must fall below a low level current called the holding current. Thus, the holding current is defined as the minimum value of anode current below which the SCR's anode current must fall for turning off the thyristor. For industrial applications, the typical value of this holding current is taken as 0. Now, the another method of triggering is dV by dt triggering. As we know, when the SCR is forward biased, that means the junction J1 and J3 they are reverse bias, and junction J2 is junction J1 and J3 are forward bias, and junction J2 is reverse bias. This whole forward voltage is across this junction J2, and here this junction J2 it behaves like a a capacitor with the stored charge around this junction or capacitor C2. It this whenever a sudden change in applied voltage occurs, this results in a charging current to reach the P2 layer of the device, and this causes this charging current behaves like a gate current, and this causes unnecessary turning on of SCR. Method of switching is never used as it is unwanted turning on of SCR, and that's why protection is used against this unwanted turning on, and this protection is done by using the snubber circuit. Now, the next method of triggering is the light triggering. In this light triggering, a beam of light falls on the inner P2 junction, which results in the formation of electron hole pair. This electron hole pairs results in the formation of a current, and when this current reaches the inner junction P2, it turns on the device. However, this method is used in LASCR, that is light activated silicon controlled rectifier, that which is used in high voltage and high current applications like HVDC transmission system, static var control extra. And what we are basically using here a fiber optical system is used to trigger these LASCRs, which provides a high electrical which provides an electrical isolation low voltage and high voltage circuits. That means between the anode cathode voltage, which is the high voltage side, and the gate cathode, which is the low voltage side.